Okay, so experiment, treatments. You guys, when I say more specific, in general, what do you always need to include in your answers? Context. So types of music were randomly assigned. So yes, those are treatments, but you should be specific and do those treatments in context. Okay? So you guys, why was there a group that didn't listen to any music? Okay, the word control group. Yes, it is a control group. That is not the why. Why would we want a control group here?
Show what results would be like without any of the treatments themselves, I guess.
See if the music actually increased it or...
See, is it the music? Is it just music that increases it and not the type of music?
Yeah.
Okay. So in this particular case, what is the probability of somebody completed the assignment? 80 out of 150, which is approximately 0.533. Okay. All right. What is the probability that somebody who listened to jazz music completed the assignment? So probability of completing of the assignment, but this time we're given that they listened to jazz. 23 out of what? Are you good at why it's 45? And guys, I'm not very smart, but I bet that's about 0.51. So, are the events completed the assignment and listened to jazz music independent of each other? Why? No. And in fact, if we were to kind of like, this makes it look like jazz music had a lower completion rate than overall. All right, now that being said, you guys, I'm very comfortable saying that within this sample, they are not independent. I am not very comfortable saying within the population that they are independent. Do you guys understand the distinction between that? And the reason I'm not very comfortable is how big a difference is there between 51% and 53%? It's not a very huge difference. Do you guys see what I'm saying here? Okay. So what we're going to do next is actually find, so for each group, so we have the jazz group, and we said 53% are completed. What percent did not complete? 47. Okay, so what if we did the same thing for the classical group? What percent of the classical group completed the assignment? Oh, got it. So 57%, give or take, and 43%. Okay.
Shouldn't jazz be 51%?
Yes. I was using that group as the whole. And then the no music group is, I'm pretty sure, 51% as well. Okay, so if music works, does all music work? Now, like, these are pretty much the same, right? So whether or not you're listening to jazz music or no music, the completion rate was about the same, so it doesn't really seem to help. The question becomes, did the classical looks like it might have helped a little bit. Yeah, because those would not be independent. The question is this difference enough to make us broaden this not just to this sample, but to the group, to as a whole? Is everybody with me, kind of? Okay. So, I want to go back to overall, the way we did the what proportion were completed. We did 80 out of 150, and we got about 0.533. So the question becomes, like, within the sample, they are definitely not independent, but just like in general, are they independent? Well, when we run it, we're going to have to do a test. We're going to do a chi-square test to decide, are these events independent? Chi-square is really good for categorical variables, and that's what these are, right? Like the type of music and whether or not someone completed the assignment or not. Categorical variables. So first thing we want to do is figure out, well, how many should have completed the assignment if they were independent? And if they were independent, this 53% should be all across the board. Are we good with that idea? So, how many for jazz should have completed it if they actually were independent? Well, we would have to say, well, what is that 53% of the people in the jazz group? How many were in the jazz group? 45. $24 even? Okay, so 24, that's fine. Okay. And for the classical group, we would do that 0.533 times the 54. Okay. And then times 51. $27.1. Okay. So, are you guys with me real quick? That 0.533 was 80 over 150, and then we did times 45. Yeah? That's essentially what we did. All right? So to find the 45 and the 80, right? Those were, so this was the expected count for just this cell. Okay? And it's essentially the row total times the column total, and then divided by the table total. Okay, so to calculate the expected counts for any given cell, you do the row total times the column total over the table total.
We had to do that, but he
Yeah.
didn't really say why. He just said, just do it.
Now you know why. But he's not explaining the math, he's explaining the science, right? I'm explaining the math, where it comes from. All right. So, let's see. We had 24, 28.78, and 27.2. And then, can we calculate these other values? You have two options, right? Like, if I expect, of the 45, I expect 24 to be completed, that means 21 should not complete, yeah? So that combined, I have a total of 45. Like, the expected number should add to the total for each column is probably the quickest way to do this. And then, so this one... should be maybe 15.22. Nah, 25.22. And then this one should be 23.8. Is this feeling okay? What are you guys laughing at? That's not me. I didn't do that. I'm assuming they didn't come back when they were told to come back. You guys. For any of these, was the expected count and the observed count the same? Now, so as you guys are looking at this table on your gut, is it possible the differences we see here could occur simply because this is a sample of students and samples aren't perfect?
Yes.
Yeah, right? So could these differences have been because by chance alone?
Yes.
It's possible, for sure. Okay, so in order for us to do this, what we're going to do is calculate a chi-squared statistic for each cell in the table. So for example, this group I could do, for this cell I would do 23 minus 24 squared over 24. For that observed minus expected squared. We could do this, and you would do this for each cell. We could add them all together. Okay? Do you guys see what's going on here? Okay, now, your conditions are all the same. Your large sample size is still going to be that your expected counts are bigger than or equal to 5. Your random condition is still going to be either random sampling or random assignment. Right? Are you guys with me on this? Okay. Yeah.
For something like this where you have like two categories for one variable, you could do one cell and then multiply by 2, right? Because it's kind of redundant. Like one's gonna go up by a certain amount and one's gonna go down by that same amount.
But the expected amount won't be the same. So the top number will be the same, the bottom number.
They'll differ by the same from the expected.
Correct.
Right?
But so like the calculation, like the contribution to chi-squared, this number would change.
Oh.
Because
Okay, yeah.
unless it was like evenly distributed, so that's why we don't just do that. Yeah.
Do we have to calculate if it's independent on the show like we did like a little earlier? Or is it the same?
Okay, so the independence condition is going to be the same of if you have random sampling, 10% condition. If you have an experiment with random assignment, you're going to say individual responses are independent. Cool? Did that answer your question? Okay, you guys, when you think about like we essentially have two sets of categories here, yes? What's the degrees of freedom for the type of music only? I have three categories, I take one away. Two. What's the degrees of freedom for completion? One. So here's the deal. You're essentially multiplying the degrees of freedom for your two variables. So you're going to take rows minus 1 times columns minus 1.
Not including the total.
Not including the total. Yeah, because the totals, as I look at this table, this is the actual data. Everything else is a summary of the actual data. Now, this next part, you're going to be like, why does it matter? I'm going to be like, it doesn't to me, but it does to them. Okay? So we had 24, 21, 28.78, 25, and then 27.2. We have two different types of chi-square tests. One is called the chi-square test for homogeneity. The other is called a chi-square test for independence. Sometimes this one can be, we would just as easily call this a chi-square test for association. I like association a little bit better, but it doesn't really matter.
These are completely different from goodness and fit tests.
These are because you have two variables. Goodness of fit test, you have one set of categories. Now we're working within two sets of categories, and we're trying to decide is one group the same or different from the other group. Okay? Not from some stated claim, but just from another group. Okay. Now, chi-square test for homogeneity is when you have different populations or different treatments. Okay? Whereas an association is like essentially one population, and you're looking for how are variables related to each other within one population, or are they related to each other within one population? The hardest part, I think, of these tests is deciding whether or not you have a chi-square test for homogeneity versus a chi-square test for association. Okay? The best rule of thumb, it is not a perfect rule of thumb, is that if your data is coming from an experiment, it's definitely a test for homogeneity. Independence, you should be asking yourself how many populations. One population is association, more than one population is homogeneity.
So that last one would be homogeneity.
Say that again.
One population goes with association. It'd be a chi-square test for association. The other one, if it's more than one population, is probably describing homogeneity. Okay, you guys, the only difference between these two tests is the name. The only difference. Everything, well, your hypotheses will be worded slightly different, but other than that, like every calculation, everything is done exactly the same. Okay? So, let's start with this one. Let's do the full setup for this one. So someone just said this would probably be a chi-square test for homogeneity because this was an experiment. Your null hypothesis is that both groups or all the groups match each other with respect to the other variable. Okay? In this case, our group is the different types of music. The other variable is completion. So my null hypothesis will be something like the completion rates are the same for each type of music. Does anybody want to guess my alternative hypothesis? They are not the same. For each type of music, which is very close to at least one is different.
If you're getting, like in this case, you're gonna get 6 individual contributions, right?
Mm-hmm.
So how do you look back and figure out which two groups differ from each other?
When we do these calculations, you're going to get expected counts, right? You're going to just look for those biggest differences. Your calculator won't give you the contributions. The way they have done that in the AP exam, and what they do is they have in the table they'll have observed count, and then in parentheses they'll have the expected count, and then they have the contribution underneath. They put them all in one table as like a data report from a chi-squared analysis, so you could do it that way. I've never seen a free response question where they ask you to do that follow-up analysis on a two-way table without them giving you the two-way table with the contributions and stuff in it. Okay. All right, you guys. Is the random condition met?
Yes.
We have random assignment of treatments. Lovely. Okay. Large sample size. All the expected counts were, in fact, greater than or equal to 5. They would expect you to write them. And then 2. 23.8. So they would expect to see those expected counts. They're usually pretty flexible. Like if you write them up here in the table like I did before, that's fine too. And then you can just state that all the expected counts. And honestly, because of questions like Landon's, like if we want to see where do we see the biggest differences, it'd be nice to kind of see them next to each other. Yeah. Okay. Last one, independence.
All responsive.
Individuals' completion of assignment are independent. Again, using the most specific language I can. Okay, now, how do I put this in my calculator? Certainly there's going to be a calculator shortcut. There always is. Yes? Did you guys use the calculator shortcut?
I'm saying I wish we did.
All right.
Because it took so long to fill out.
Are you allowed to use the calculator on the AP Bio exam?
I think so, yeah, because we have certain formulas.
Okay. All right, you guys. Are you guys with me that the information here is, first of all, those 6 cells in the middle, right? The totals are the summary of what those 6 raw data cells tell us. Okay? And it's almost like the order, like it's important that this is in column 2, row 2. Does that make sense? So the way we tell the data to our calculator, I can't just put this in L1 and L2, because if I try to just put it into L1 and L2, it doesn't respect the general location. Does that make sense? Okay, so here's what we're going to do. We are going to enter this data as a matrix. You forget how to get there? So, I do this every year, not just because you said this, okay, Sam? You guys, if you don't know where to find the matrix, just stare at your calculator long enough. It's not even abbreviated. It says matrix right there, okay? So go ahead and hit second in the x to the negative 1. All right? And what we need to do, we don't want to just look at a matrix. We want to go over to edit because we want to edit our matrix. All right. The first thing you're going to want to edit is the size of your matrix. You want this to be 2 by 3. It's rows by columns. If you screw it up, go back and re-edit it. If it doesn't look right, just go back and fix it. Everybody good? And let's go ahead and put in that information. So we had 23, 31. You are putting in the observed counts. That's what your calculator needs. And in fact, that is all your calculator needs. Because it can use the observed counts to figure out the expected counts. Everybody with me? Once it has a complete table, it can calculate the expected counts for us. Everybody good? All right, then we're going to go stat, arrow over to test. We're going to pick the one that is appropriate, which is the chi-squared test. This is not a GOF test, so I shouldn't pick GOF test. Now, this is the kicker. This is great, okay? The first box that you fill in, observed, is where did you put the observed counts? This is what your calculator is asking. Where did you put the observed counts? For the expected, the calculator is saying, where would you like me to store your expected counts? You don't even need to clear it out. It'll automatically overwrite it. Everybody good? So literally once I get the matrix in, I go ahead and hit enter. And let's go ahead and write this down. We've got chi-squared equals 0.563, which is a very small value for chi-squared. My p-value, not surprisingly, is very, very large. Now, you guys, remember when I said, hey, is this, like when we just do this comparison of the observed and the expected counts, could it be that this was just because of sampling? And we're all like, yeah, that makes sense with this really large p-value. Notice that it also even tells you your degrees of freedom. That does not tell you the contributions. No. Didn't we just have this conversation?
We did?
Yeah.
Was it in Landon?
So the only time they've ever asked questions, like they will give you a table and it'll have the observed count, the expected count, and the contribution. And they'll give you the contributions if you have to do an analysis using the contributions. They do not expect you to calculate all of them by hand. That's insane. Especially, I don't know. I don't know the answer. Okay, now you guys, if I go back to that matrix menu and I go to my matrix B, I don't know if you guys saw, but before my matrix B was 2 by 2. Now it's a 2 by 3. If I hit enter and look at that matrix, notice I'm getting the exact same thing as our expected counts.
So would you use that to calculate?
So I actually, when I do these, I actually do the top right box first. Like I get my calculations, then I check my conditions because I'll have the expected counts at that point. Hey, you guys, what are we concluding here? I do think 75% is bigger than 5%. We fail to reject the null. You guys, if I don't reject the null, therefore, we cannot conclude. The completion rates are different for the different types of music. Everybody good?